Hey guys, welcome to another proactive tutoring lesson. I'm your host Albert, and in this video, we'll be looking at how to interpret data figures, or basically answer graph and chart related questions on the SAT reading section. Let's get started. Okay, so in recent years, the SAT has been trying to test students more on science and math skills and been trying to incorporate that within different subjects. So they've begun to include like graphs or chart related stuff on the SAT reading section. And to answer these questions, you basically use the same skills that you learned in your science class or math class for how to answer questions in charts, like answering like the maximums, the minimums, the trends in the graphs, stuff like that. And oftentimes how they get you on these questions is they often overwhelm you with too much information. They provide like too many graphs and the question's only asking for like some of that, so only one of the graphs. So look for key details in the questions, like keywords, so that you can answer these questions quickly, efficiently, but still correctly. But at the same time, you don't want to be like make careless mistakes. So make sure you read the data carefully. Like don't mistake one graph for another graph. That's how like people make careless mistakes, and that's often also how they get you on these SATs. And going off of what I said earlier, you use the similar skills learned in science and math to answer these questions. So if you need more practice or more help, I encourage you to check out our ACT science videos or our math videos on interpreting data figures for more practice. Let's try an example. So here's an example of a question you might see on the SAT reading section on how to interpret graphs. So I encourage you to pause the video, answer this question. In a few minutes, I'll go back and review it with you guys. All right, I assume you guys have answered this question, so let's get into it. Data in the graph, this graph right here, indicates that the greatest difference between the per pound profits from fair trade coffee and those from regular coffee, so between fair trade coffee and those from regular coffee occurred during which period? And it's asking for the greatest difference, right? So looking at this line right here represents the fair trade coffee, and this line right here represents the regular coffee, right? And whenever it's asking for greatest difference, you try and look for the greatest distance between the two graphs. So in which part is the distance between these two graphs the greatest, right? That's like the quickest way to answer it. Like you could also like try and find like calculations like 130 right here and 40 right here and try and subtract and all that. However, that's not how the SAT wants you to answer this question, because you often waste time when you're doing that. So you just analyze the general trends. So which part right here is the greatest difference, right? So where on this graph is the greatest distance between the two lines? Well, that would be right here, right? Since this one's way up here and this one's way down here. So this section right here has the greatest difference, and that is between 2002, 2003, and 2004. So that matches with answer choice B. The greatest difference between profits between fair trade coffee up here and regular coffee down here occurs between 2002 and 2004, where the lines are the greatest distance apart from each other. Great job, guys. Let's try another one. Okay, so similar to before, take some time to pause the video, answer this question, and I'll review it with you guys in a bit. So this question is asking, which choice is supported by the data in the first figure? So you see they try to overwhelm you with too much information by giving you two figures, but they only require information from the first figure, this figure, right? So in this figure, it's talking about the primary occupation of public transportation passengers in US cities. So out of all the people in the US cities, how many of them are all the people that use public transportation in US cities, how many of them are employed outside the home, unemployed, students, homemakers, retired, etc., right? So which of these statements in the question matches the data provided in figure 1? So the number of students using public transportation is greater than the number of retirees using public transportation. Well, the number of students using public transportation out of the total, so 10.7% of the population in US, 10.7% of public transportation passengers in US cities are students, right? So these are students. And number of retirees, the percentage that use public transport, the number of public transportation passengers that are retirees in US cities is 6.7%, right? So 10.7, the number of the students, is much greater, it's greater than 6.7, the retirees, right? So answer choice A, and that seems to match with the statement in answer choice A. So this seems to be correct. So we'll mark that and then see if there's a better option. Answer choice B is asking the number of employed people using public transportation and the number of unemployed people using public transportation is roughly the same. Well, the number of employed people using public transportation is 72%, right? And the number of unemployed people is only 6.4%. Now, 72 is much bigger than 6.4%, so it's not exactly roughly the same. So this answer choice is a false statement, so we can eliminate that. Answer choice C is saying the people employed outside the home are less likely to use public transportation than our homemakers. However, the less likely here makes this question kind of iffy, right? Because based on this graph, it's not a prediction of whether you're more likely to use public transportation or not, right? This is just a makeup of all the passengers in US cities, and it's asking employed outside the home versus all the other, like how many of them have this job, how many of them are students, etc. So you can't really predict anything from that. Like you can't predict based on if you are employed outside the home, are you more likely to use public transportation or are you homemakers? That's not exactly what the graph represents, right? So this question is also wrong in that the people that are employed outside the home is 72%, and the homemakers are only 2%. So that also doesn't really match up. So answer choice C is wrong. And answer choice D, similar to what we covered in answer choice C, the less often right here, as I stated before, this figure isn't exactly a predictor of whether you're more likely to use public transportation or not, right? So unemployed people use public transportation less often than do people employed outside the home. So unemployed is 6.4%. This is 72%. So even though this is where it might trick you, because even though 6.4% is less than 72%, that's not really what the graph represents. The graph is just saying that out of all the people that use public transportation, this number of people are unemployed and this number of people are employed, right? So it doesn't really match up, because what if the number of unemployed people is less than the number of employed people? So that doesn't really match up with the less often statement. So this is wrong. And that leaves us with the correct answer choice of A. The number of students using public transportation, 10.7%, is greater than the number of retirees using public transportation, 6.7%. And that's the correct answer. Great job, guys. Let's try another one. So take some time to pause the video, I'll answer this question, and in a bit, I'll go over it with you. So let's get into it. According to the information in the graph, when the microscope tip is moving away from the salt surface and is 15 nanometers from the surface, what is the approximate force on the microscope tip in micronewtons, right? So the key words right here are that it is moving away from the salt surface. So you would focus in on this graph, because this graph represents the tip moving away from the salt surface. So you see, this is where the SAT is trying to overwhelm you by giving you too much information. The top graph you don't really need for this question. So when in this graph, when the microscope tip is 15 nanometers from the surface, so 15 nanometers from the surface, what is the approximate force on the tip in micronewtons? So the force is represented here. So when you're answering this graph, so at 15 nanometers, the force would be right here, right? This is where the graph is. So the force would be right here, somewhere between 0.5 and 1.0, right? So out of these answer choices, 0 isn't incorrect because 0 is down here, right? So that's not between 0.5 and 1. So this isn't correct. 0.25 is also too low, right? 0.25 is right here, and that's not between 0.5 and 1. So this is wrong. 0.75 seems to be correct because 0.75 is a value between 0.5 and 1, and it seems to be roughly equidistant. Seems to be in the graph. The point on the graph seems to be equidistant from 0.5 and 1. So that seems to be correct. We'll mark that. And 1.25 is way too high. 1.25 is way up here, and that's not between 0.5 and 1. So that's incorrect. And that ultimately leaves us with answer choice C as the correct answer. So when the microscope tip is 15 nanometers from the surface, the approximate force is 0.75 micronewtons. And that's the correct answer. Great job, guys. All right. So that concludes our lesson for today. As usual, here are our social medias as well as our contact information. If you have any questions, comments, or concerns, please contact us via here. Also, please check out our Google Classroom for additional practice worksheets as well as the answer keys for interpreting data figures. And if I hope you guys enjoyed the video, and please like and comment below if you have anything to say. And I'll see you guys next time. Thank you for watching. Bye-bye.